So let's start our today's session. Please write down your name in the chat area so that I know you're here as usual. And we'll continue with section 13.4 shortly. So we were learning about the cross product. The cross product is a vector. Cross product of two vectors in 3 space is another vector in 3-dimensional space. And that new vector has the property of being perpendicular to the 2 that you start with. So if you start with 2, that third one will be perpendicular to the 2 that you had initially. If I can make it. I have 2 vectors, is green pen and the black pen, and the orange has to be perpendicular to both. That's how it is, and its magnitude is the product of the magnitudes of the 2 others times the sine of the angle between them. Okay, and last class we deduced formula for it. Let me remind you, this is the kind of work we did last time. We first learned how to do the basic vectors, how to do I, j, and k. And we know that if we do I cross I, we get 0. If you do j cross j, we get 0. If you do k cross k, we get 0. And we also learned that if you do I cross j, you get k, j cross k, you get I, and k cross I, you get j. So this circle helps, right? And thanks to that, we could use also the distributive property. So we write our vectors u1, u2, u3, v1, v2, v3 with I, j, and k, like here. Then we just FOIL it, right? Multiply everything with everything here. We got this list. And here, all these cross ones are 0 because they're kk, jj, or ii. And all the other ones we can change, right? Like this one, j cross I is negative k. So we're going the opposite direction. So that one is negative k. K cross I, k cross I, that one is j. So that one is this one over here, perfectly fine. All right? So we simplified it and we got this formula over here. And the thing is, this is not an easy formula for us to remember. The better way to remember how to figure out the cross product of 2 vectors is if we write it down as a determinant. This determinant, where we put the vectors I, j, and k in the top, then the coordinates of the u vector, the components, x component, y component, z component, then the components of the v vector, and then this is the answer. And this, by definition, is done as follows. So you pick a row and you go positive, negative, positive, positive, negative, positive. And whatever elements you pick, if you pick I, you cover that row and that column. And what remains, these U2, U3, V2, V3, that's this little 2 by 2 determinant. Then you go to J. So now you cover this one and the top one. So what remains is U1, V1, U3, V3, and that's this one over here. And for the last one, you cover the last column and the first row. And what remains is this one, U1, U2, V1, V2. And to do the 2 by 2s is super easy. You just go in this diagonal, positive, and then minus this diagonal, right? So this one positive, the opposite one negative. I even told you of an alternative way of doing a 3 by 3 determinant. This, by the way, determinants can be done, if you ever take linear algebra, you will see that you can do even bigger determinants, like 4 by 4, 5 by 5, you know, as big, you know, 1,000 by 1,000, it's possible, right? And this way of doing it works in general, whereas this one only works for 3 by 3s. So this is an alternative way of figuring out the cross product of u and v. And what you can do is write the three rows of the determinant, copy the next 2 over here, and then go positive on the diagonals that go from left to right down, and negative for the diagonals that go left to right up. And when you do it, you get the same answer as this one over here. Okay? All right, so that's a summary of what we did last time. What we're going to be doing now is some exercises. So let's start by calculating an example. Let me show you first diagrams from the book. So this is the circular arrangement that reminds you how they goes. And you can tell over here how I cross J gives you K, because you follow the right-hand rule, remember? So you go from I, so I through J, and then K points in the opposite, in the up direction, and that's why I cross J gives you K, and so on for these ones over here. And then here at the bottom, you can find the summary of what we've done. Okay, so let's start with that example 3. Example 3 says find the area of the triangle. Now, this is a little bit weird because the area of the triangle seems unrelated to cross product, but you need to remember what we learned, right? You need to remember that the area of a parallelogram, it's the magnitude of the cross product. Let me remind you about that. So this is the important thing. We did it also yesterday, the previous class. If you have two vectors and you do the cross product, the area of this parallelogram is precisely the magnitude of the cross product. Now, in the problem we're going to do right now, it's not about the area of a parallelogram, it's about the area of a triangle. Well, but that's easy because the triangle, if you want just the triangle is just half of the parallelogram, right? So if you want the parallelogram, you do the magnitude of U cross V. If you want the triangle, exactly, divide by 2. That's all you need to do. Divide by 2, as Luis said, right? So that's what we're going to do. So our example right now, we have, put it back on the screen. It says, find the area of the triangle with vertices 0, 0, 0. So the vertices are the origin. It's good. The point 2, 3, 4. And the point 3, 2, 0. And I'm going to show you so you can see the diagram right there. So there's a diagram in 3 space. So we have the origin is going to be one of them. Then we have this 2 other vectors, a red one and a blue one. So let's do the blue one. So the blue one is from here to here. Mine is a bit thicker. That's 3, the vector with components, the vector OQ with components 3, 2, 0. And then you also have the red one. From here to here. And that is the vector OP. And that has components 2, 3, 4. And just as I was telling you, if you do the cross product and then find the magnitude of the cross product, we can find the area of this parallelogram that you see on the screen. Now, we don't want the area of the parallelogram, we want the area of the triangle, that light blue triangle. To get the area of that light blue triangle, what we do is take the area of the parallelogram and we simply divide it by 2. Okay, so it's right here. 1/2 of the cross product is what we need to do. Okay, let me erase the drawings. So let's go back to the page. That's our plan. So we know that the area of OPQ is 1/2 the cross product of OQ with OP. Now, should I do OQ times OP or OP times OQ? Does it matter? Because remember, cross product matters, right? If you do the opposite one, you don't get the same thing. And even though you don't get the same thing, when you switch them, you get the negative of the other one. And since here we have the length of one or its negative is the same, right? So it doesn't matter here for the order. If you only want to get the area, it doesn't matter. You can do OQ cross OP, or you can do OP cross OQ. So we just make a little note here. Order does not matter. Does not matter for magnitude. So it matters for the actual cross product because then it points in the opposite direction, but it doesn't matter for the magnitude, okay? Now, here we were also lucky that they gave us the origin as one of the points, so it's obvious that you want to use that one. So later on, we'll talk about how to do it. We'll do some problems where the 3 points, not all of, we don't have the origin among the 3 points, right? What to do then? And you have to pick one to work as the origin, and we're gonna figure out how you can do that. All right, so let's do the cross product. So how do we do the cross product? So OQ cross OP. Well, we said we put these I, J, K. Then we put the components of OQ. The components of OQ are 3, 2, 0. Then the components of OP, 2, 3, 4. Good. Now we follow on our way of doing it. So it's I times this little one, right? So if you do I, you obtain this one over here, right? Because you're covering this row and this column. So what remains is 2034. Then you go to J, and you go J to cover that column. So the ones that remain are 3, 2, and 0, 4. And with J, you have a negative sign. Don't forget about that. And then you go K. K is again positive. For K, you cover the last one. So now you have this 3, 2, 2, 3. All right, you're with me? Once you know the procedure, it's actually straightforward. So cross product, you should not be scared about the cross product. It's just, you know, there's a little bit of a drag that you need to work this out, right? But it's actually pretty straightforward. So now let's do this. It's 2 times 4 minus 3 times 0. This one is 3 times 4 minus 2 times 0. And the last one is 3 times 3. These are vectors, I always forget, minus 2 times 2. Right? Good. So what is it? 2 times 4, 8. 3 times 4, 12. Minus nothing. And 3 times 3, 9. Minus 2 times 2, 4. 9 minus 4 is 5. So the answer is 8i minus 12j plus 5k. Or you can write it like this, 8 negative 12, 5. Right? Either way. So that's the cross product of those two vectors. Now to get the area, let's not forget that was our problem, right? Getting the area. We need to find the magnitude and divide by 2. So let's do it. So the area of the triangle OPQ is 1/2 the magnitude of this guy. And that's 1/2 the magnitude of 8 negative 12, 5, which, how do we get it? Is we do square root, this number square, negative 12 square, 5 squared, right? That's 64 plus 144 plus 25. And this is 169 plus 64. Whatever that number is, 233. And that's it. I don't think I can simplify this further. Oh, where's the 1/2? I lost the 1/2. Don't do that. It's important, right? So it's 1/2 of that. 1/2 of the square root of 233. And that's it. All right? Is it clear? How we do it is pretty straightforward, as I was telling you. So there's two things you need to remember about the cross product. Well, three. You need to know how to get it. You need to know that you can get the area of a triangle or the area of a parallelogram using the magnitude or half the magnitude. And you need to remember that the cross product is perpendicular to the two other vectors. So this vector over here, this vector 8, negative 12, 5, is perpendicular to 3, 2, 0 and to 2, 3, 4. Right? So it's in a plane that's perpendicular to both. And that's instructive and useful many, many times. All right, let's do more problems. We're only gonna do problems now. Get some practice here. So let's do the next example. Example 4. Example 4, it says, find a vector orthogonal to the two vectors u equals negative I plus 6k and v 2i minus 5j minus 3k. All right. So this goes into the second thing I told you you should remember. So whenever you want an orthogonal vector to two others, one great candidate is the cross product. So the cross product will work. The cross product has the property of being orthogonal to both, right? So let's calculate it. So we can add, you can do u cross v or v cross u. Both of them will work, right? So you have two vectors. One of them will be the one that points towards me right now, the green one that points towards me. The other will be the one that points towards the screen, right? This one or that one, but both of them are perpendicular or orthogonal to both of the other ones. So either one of them will work. And in fact, once you find one, you can always multiply, you can enlarge it or shrink it, and that one will work as well. Okay, so let's write it here, u cross v. Let's set it up. What is it? Big determinant, I, j, k, and then the u is negative 1, no j, and k is 6. The v is 2, negative 5, and negative 3. Boom. So then this is I. Remember, cover this one. So it's 0, 6, negative 5, 3. Negative 3. Minus. Cover the middle one. So it's negative 1, 2, 6, negative 3. And plus k. Cover the last one. And it's negative 1, 0, 2, negative 5. Good. Let's continue. Okay, how do you do these little ones? It's easy, right? Multiply this diagonal from from top to bottom, left to right, that's 0 times -3. And then minus the one that goes from bottom to top as you go from left to right. So it's -5 times 6 minus j, -1 times -3 minus 2 times 6 plus k, -1 times -5 minus 2 times 0. Okay, let's see. This is 0, and this is -30 with this minus, it's 30. This is +3 minus 12, so that's -9. And this is +5 minus nothing, that's 5. So altogether, this is a vector 30, minus times minus is plus, 9, 5. Okay, go slow so that you don't make silly mistakes, right? See, here's the thing with these cross-product problems. There's tons of places where you can make a silly mistake. A sign, a number that you copied wrong, right? So give yourself time to do it, you know, steadily and correctly, because you don't want to make a tiny mistake that, you know, makes it all wrong after that. Okay, so this is our proposed answer, that this is a vector that is perpendicular to the both of them. Let's check it. We haven't checked. Now remember, this is actually not from this section, this is from the previous one. How can you easily check if two vectors are orthogonal?
If their dot product is 0.
Correct, thank you. If two vectors are orthogonal. Yes, as Michael just said, we can check their dot product. Answer, the dot product is 0. So let's check the dot product. So what would be the dot product of u with this one, 39.5? And then let's recall that u is -1, 0, 6. And we're doing the dot product with 39.5. And the dot product is easy, right? We just multiply the corresponding ones. So this is -1 times 30 plus 0 times 9 plus 6 times 5. This is 0, and this is -30 plus 30. 0. Yes, they are orthogonal, right? So that's our check. Now let's do V. What is V dot 39.5? Well, V is 2, -5, -3. Dot product 39.5. It will be 2 times 30 minus 5 times 9 minus 3 times 5. That's 60 minus 45 minus 15. 0. Yes. All right. So that just reassures me that we did everything wrong. I didn't make a mistake, or if I did, it didn't matter because I still found a vector which is orthogonal to both the ones that were given to me. All right. Very good. Now, if you want more, so here's an extra question. What if we don't want an arbitrary orthogonal vector? What if we want a unit orthogonal vector, right? So let's modify the question. Let's imagine that the question was harder. Let's imagine that the question was to find a unit vector perpendicular. So what if we want a unit vector perpendicular to both u and v, or orthogonal? Remember, perpendicular and orthogonal are almost synonyms. The only difference is that the 0 vector is both orthogonal to both as well, right? So in this case, a possible answer would have been to do the 0, 0, 0 vector, because the 0, 0, 0 vector is orthogonal to both u and v. as well. But that's kind of like cheating, right? So this is a better question. Perpendicular. Perpendicular immediately tells you that it has to be a non-zero vector. Okay? So how do we answer this? Well, we already have one that works, but it's not unit. Yes, this one works. Sadly, it's not a unit vector. So, but come on, we already learned how to do that, right? How do we find a unit vector that points in the same direction? How do we do that? So what we'll do is find a unit vector in the direction of 39.5. We already know this one works. We divide by its magnitude, right? If we divide by its magnitude, then we shrink it so that it becomes unit, or we enlarge it. If it's tiny and you divide by a small number, then it becomes bigger, right? So what is the magnitude of 39.5? Will be the square root of 30 squared plus 9 squared plus 5 squared. That's 900 plus 81 plus 25. This is, what is it, 981. 981 plus 20 is 1001, plus 5 is 1006. I'll probably leave it like that. Maybe it can be simplified, I don't know. But then what is the unit vector I want? So here it is 1 over the square root of 1006 times the vector 39.5, which is 30 over the square root of 1006, 9 over the square root of 1006, and 5 over the square root of 1006. And believe it or not, this is a unit vector, right? It kind of makes sense because when we do the length of this one, it will be like the length of this, which is 1000 square root of 1006, divided by the square root of 1006. So it will be 1. All right? So either way, we got it. We can get that question. All right. So let's do some problems. We have scheduled for the day to continue talking about 13.4, and we still have like half an hour or so. So let's look at the book. So in the book, there are a few applications about physics and forces that we could talk about them, but they're not on the final exam. They haven't been for some semesters. So I think instead, we should concentrate on the kind of problems that you may be asked for the final exam. So let's look at page 842, where we have the problems, some of the problems, and let's work on a few of these. Now it's going to be the time where you guys, I would like you guys to do a little bit of work here. All right, so let's, all of you, I want you to work on problems 25 and, well, let's do 26. So problem 26 for everyone. Problem 26. All right? So you need to calculate both of them, U cross B and B cross U. And let's go. Everyone do it. Take a piece of paper and get the work. Start doing this one, and hopefully one of you will share your solution with the class. You can click on share your screen, put it on the camera, and show it to me when you're done with it. All right? I'll work it out myself. Let's give ourselves 5 minutes or so. All right, how are we doing? right, I see a few of you are already done. Let's wait a little bit more. All right, so let's start with Luis. All right, can you? Okay, only the. Let me just. Okay, let's try it again, Michael. I changed the setting. So if you're using a video, if you're using video, just put it in front. Just put your solution in front of the camera. And we'll take a look at it.
Could you see what I'm showing? Or
We see a screen that says you are sharing screen.
hold on.
All right, Luis, I see you. Okay, let me see Luis's. All right.
This is a little hard.
Yeah, just put it closer. Yeah, like that. Good. All right, a little bit. We want to see the lower part. So scroll up.
Is that fine?
So you got -2, 3J, and 10K. 3, -4. Okay, let me see the top a little bit. Okay, I didn't have the same answer, but maybe I made a mistake. So let me let's can you show us the answer at the bottom, Luis? So Luis has vector is -2, -2i, 3j, and 10k. Thank you. All right, let's see Michael's.
Yeah, I got this.
8, -9, -10. Okay. Yeah, I have a similar one to that one. So maybe you did a little mistake somewhere along there, Luis. You can check it now. Could you turn it 90 degrees, your notebook? There you go. Thank you. We look at it sideways. Yeah. Yeah, that one looks like the one I only did one of them. By the way, you don't need to do the work for both, right? You can always you know the property that if you switch the order, you just do the negative of the answer. So it was enough to do one of them and then simply change the negative of the answer. As you can tell here from Michael's solutions, it's almost the same, right? We just change the sign on one of them. Mm-hmm. Yeah, that looks about correct. Anyone else wants to want to share? If not, let me show you my solution, which is about the same as Michael's, I think. So this is the one that I did. So just like I said, it's just a matter of going slowly, right? So that you don't make mistakes. So 3, -4, 6, 1, 2, -1. That was the first one I did. Wrote the determinants, did them here. So 4 - 12, and -3 - 6, and then 6 minus -4, so that's +4, and my answer was -8, 9j, 10k, right? As an easy check, you can always uh, do the dot product with the previous ones to see if you are correct or not. Okay, very good. Good job, guys. Let's do another one. So let's start it out. Let me put the book again. And this time I want to do one where we need to calculate the area or the of some triangle or parallelogram. And so let's go to the next page. And I want us now all to try problem 35. I'll show it on the screen in a moment if you don't have the book with you. So right here, 35. Arrows, 35. This one. Okay, let's give it 5 minutes. So this time we have three points in three-dimensional space, and we want to find out the area of the triangle. And it's a triangle, you know, right there in space, right? So it's difficult to find it in a different way. If you wanted to find it directly, you would need to are we looking for AB and AC? Yeah, so that's the thing, right? That's the point that I was trying to make the other time. So you get to decide where you want to do the vectors, right? If you want to use the cross product, you can pick the vector AB and AC, or you can do the vector BA and BC, or you can do the vector CA and CB, and all of them are going to work, okay? All of them will work, so it won't be a problem. So you just need to pick one, and oftentimes, well, it's not clear actually which one is the better to pick a priori, right? And maybe you would like to minimize the number of calculations that you need to do, but pick one to be the point where your two vectors will start, okay? All right, so let's give it some time, and you just let me know. All right, if you're already done, as I see a few of you are, just for practice, try it again, picking a different vertex as the one that originates the two vectors. All right, see if you get the same answer. All right, Luis, let's see your solution.
I got 1/2 square root 128. Let me see.
Mm-hmm. Okay, and well, you picked A as a one.
Okay. AB and AC.
Good. And your vector was, your cross product was 8I minus 8K. Good job.
Yeah.
Looks correct.
Okay.
Looks what the same one I got. Remind you, I'll mark you as a participation point, same as before with Michael. Okay.
All right.
Thank you. How about you, Michael?
All right, so this is what I got for the vector. 2, 0, -2. Oh wait, is it sideways?
No, you were right actually.
Oh, this way?
Yeah.
Okay, so I got 2, 0, -2.
You didn't get that one either.
Oh, because I did AB times AC.
So AB, let's take a look at your vector. Your vector AB doesn't look right. So should be, so the point B, I think the point B was 7, 16, 4.
Oh, I put 10. Okay.
Yeah. But okay, you did a different problem. It looks about right.
Okay.
Mm-hmm. Good. Anyone else wants to share? Daniel? Okay, let's see. You picked AB again, okay? And your answer was 8, 0, negative 8. Okay, good. And you, good, very nice. Let me write your name as well. Okay. Let me go back to my screen. Okay, and here's the one I did first. So first I did a with anchor in A. So I did AC and AB. And remember, to do AC, you do the head minus the tail, right? That's what we do. And, same with AB. So for AB is 6 minus 5, 1, 7 minus 6, 1, 3 minus 2, 1, 1, 1, 1. And then with AB is 7 minus 5, 2, 16 minus 6, 10, 4 minus 2, 2. Then I did this, calculated the cross product, and you'll see it right here. And we got negative 808, just like Luis and Daniel showed. I think Daniel got 8, 0, negative 8 because he did AB cross AC, and AB is the other way around, right? But it doesn't matter because the magnitude is still the same. So it's still the square root of 128 divided by 2, or if you simplify it, 4 square root of 2. And just for kicks, I also did it, well, what if I pick C, right? What if I do CA and CB? Could that change anything, right? And if you do CA, now it's CA. Now this is the tail. So now head minus tail is be 5 minus 6, 6 minus 7, 2 minus 3. So we got negative 1, negative 1, negative 1. And then for CB is 7 minus 6, 1, 16 minus 7, 9, and 4 minus 3, 1. So you get 1, 9, 1, this one over here. And notice how when you do the cross product, I didn't even continue anymore because my vector, my cross product vector is the same, right? These two vectors are the same. And because they are the same, when I do the magnitude and half, I'm gonna get the same answer, right? I'm gonna get the 4 square root of 2 answer that we had gotten all before. Okay, so like I said, most of these problems are really straightforward, and yeah, there's not much to it. So you just need to remember the properties of the cross product. You can get the area of triangles or square or parallelograms this way, how we do it right now. And that vector is orthogonal to the two others, right? That's a way we can check. In fact, let's check this one here. Is this vector orthogonal to that one? Let's do the dot product. So what is the dot product of negative 1, negative 1, negative 1? Dot product, negative 8, 0, 8. Well, that would be negative 8 times negative 1. That's 8, 0. And negative 1 times 8. That's negative 8. 0. Great. How about the other one? Well, 191 with negative 808. So 1 times negative 8, 9 times 0, and 1 times 8. 0 again, right? So it works. It works in both cases. Okay, let me do one last problem, and that's another possible issue of using the cross product, and that is to check. So let me go back to the book. And right here in something like any of these, like 40, for example, problem 40, and it says use cross product to determine whether the points A, B, and C are collinear. And remember, for collinear, the cross product of vectors that are parallel, that point in the same direction, is 0. So to figure out perpendicular, you use the dot product. For perpendicular, dot product is 0. For pointing in the same direction or in parallel direction, right, in particular for collinear points, they are all, any two vectors will be parallel. And for vectors that are parallel, the cross product should be 0. So that's one way of doing this, right? We can do the cross product. So the way to check if they are collinear is to do the cross product of any of these two vectors and check if it's 0 or not. If it's 0, they are collinear. If it's not 0, then they are not collinear, right? So let's do it. So in this case, A is 3, 2, 1, B 5, 4, 7, and C 9, 8, 19. And just as with the previous problem, you get to decide where do you want the anchor for these vectors. So I think I'm gonna pick the smaller one, so A as the anchor. So what are my AB and AC vectors? Well, AB will be 5 minus 3, 2, 4 minus 2, 2, 7 minus 1, 6. What is my AC vector? My AC vector will be 9 minus 3, 6, 8 minus 2, 6, 19 minus 1, 18. Right? And okay, here maybe the cross product is going to be, see, here's another way of knowing that they are collinear in this. See, if I take this vector and I multiply it by 3, I get the other one, right? So I don't even need to do the cross product. I'll do it anyways, but here, note that AC is 3 times AB, right? If I multiply this one times 3, I get the other one. So that means they are collinear. So I have one vector, which is AC, and AB, sorry, the other way around. I have a vector AB, and AC is 3 times that one. So like that, points in the same direction. So of course they are collinear, right? Because they're in a line. One vector times a constant is the other one. But let's do it with the cross product anyway. So what will be the cross product? To IJK 2, 2, 6, 6, 6, 18. And you do I 2, 6, 6, 18 minus J 2, 6, 6, 18 plus K 2, 6, 2, 2, my bad, 2, 2, 6, 6, right? And what is this? This is 2 times 18, that's 36 minus 6 times 6. 36 minus 36. 2 times 18, 36 minus 36. And over here, 2 times 6, 12 minus 12. So they're all zeros. So it's 0i plus 0j plus 0k. So that's the 0 vector. So 0, 0, 0. And because we got the 0 vector, A, B, and C are collinear. Like I said, this wasn't the easiest way. The easiest way was here, right? When we realized that this vector is the other one times a constant. Once you know that, then that's it. It means they are collinear. Okay? So that's the only other one that I wanted to tell you about. Good. So let me tell you where we're going. So the next section in the book, 13.5, we don't do that one. Or 13.6, so we skip those two. So we're gonna start chapter 14, and that's our last chapter of the semester. And it's about vector values functions. And yeah, again, it's all of these will be mostly an introduction to Math 250 for those of you that need to take that class. So we're starting a new chapter next class. Before I sign off, are there any questions? Oh, your exams have been graded in case you didn't see yet, right? And I created them with a rubric. You guys did actually quite well, as I expected it, given that it was a 24-hour exam, and it was essentially like the type of exams that I would assign if it was during class time. So you guys did quite well. I think the average was like 82, and we had a bunch of scores in the hundreds, at least 10, I believe, 10 perfect scores. So keep it up. That's good. The next exam will be in a similar, done in a similar way. And the final exam will also be done as a 24-hour exam. The difference is we have it the same exam, or maybe there are different versions, but essentially the same exam because it's a coordinated class, and also it will be graded by all of us professors, right? We'll we'll each grade one problem or part of one problem, and we'll combine it all together in the end. Can I go back to the last example? Sure, I can. Let me put it on the screen. Anything else, guys? Also, I'll remind you, even if you, so I continuously, so as soon as I finish the class, I start editing and then uploading the video to YouTube. So even if you don't see the link on our Canvas page for the YouTube video, just check them out on the YouTube playlist, or just search it up in YouTube. Chances are that the video is already there. So you can always go back and at your leisure go over whatever we did. Oftentimes I edit them, so I cut the unnecessary pauses, or I put a little annotations of things that were not quite correct or that had to be explained a little bit better, things like that. So it's a great resource. All the videos are titled my last name, Abrego, then Math 150B. And I posted a playlist on our Canvas page. At the top, there's a playlist, and that will take you to the entire list of all the videos that we have had so far. What is, Nancy asked, what is the last chapter we're gonna cover? And it is chapter 14 is the last one we're gonna cover, and I don't think we do all of it actually. I need to go back and check, but we only do part of chapter 14. All right, good guys. I'll see you tomorrow. Stay safe.